We have this theory about how our software should work, and in practice, it doesn't quite happen that way because there's friction that gets in the way of things going according to the way it's out on paper. Consumers have 3 friction budgets. They can only deal with so much friction of wasting their time. And after that budget is used up, they get very frustrated. They have a friction budget of money, and they are only willing to spend so much money, whatever it happens to be worth to them. And if you trip over the edge of that friction budget, you are going to have them leave. And there's another friction budget that they have, which I'm going to call angst. Angst. I am worried. I am concerned. I don't feel like this is going to get me where I want to go. I am anxious. So angst. This is the Uber, or in our country, Lyft also. But what they did, why they're so successful every place they go, because they have taken the friction out of the process of getting from here to there with a taxi. This is what I'll call a full stack solution. It solves the time, from the time I want to ride until I land where I want to go. It's all handled by this company that has a trustworthy process that works the same around the world. And by the way, all these drivers kind of like it too, because it's spare income for them. We really have 2 systems of thinking. And for simplicity, call them System 1 and System 2. System 1 might be thought of as sort of the emotional system, and System 2 might be sort of thought of as the thinking system. In System 1, you have people thinking fast, making quick, snap decisions. In System 2, people take some time and consider things more. Now, you use both systems, sometimes one, sometimes another. Friction is the cognitive overhead that a system places on those who use it. So if our system puts our users into you have to think mode, if our consumers have to think and can't use their System 1, then that cognitive overload is friction. So think of your consumers as System 1 people and get rid of any friction that causes them to have to think. You should always design for System 1 because you want to place the least cognitive load you possibly can on your consumers. That's what confirmation bias is. People, everybody, me included, you guys for sure, we seek out and interpret information in a way that confirms our pre-existing conditions. Half of the time, the product manager is wrong. Microsoft did a study of their product managers that by actually looking at the data, rather than using the instinct, the intuition of the product managers, you got right way more frequently. And it actually gets worse, because confirmation bias turns into conformity bias when you have a group working together. Whatever the bias of the majority of that group is will become the bias of the whole group, and it will be a stronger bias than that individual held. And that is why big data has become such a big deal here these days, is because people have discovered that when you make decisions based on gathered data rather than a group having an idea and reinforcing each other, you get better decisions, especially if you're trying to drive some economic indicator in the right direction. Look at people who are using your thing. Watch the journey that they are taking and see how that journey can be improved. How do people know what to do? It's a very interesting question. And the typical answer is, oh, we have a roadmap. The problem with a roadmap is that half of the stuff is wrong. Because remember, half the time the product managers are, half the stuff on the roadmap is wrong. So I want to show you a different concept, a concept that a designer would use to know what to do. Creators need an immediate connection with what they are creating. And you can start with a roadmap, half of which is wrong, or you can create an immediate connection between the creators, the product team, and what they create. So I am proposing a process. You start with some signals or some patterns that you notice. Something is a little bit wrong about on this page. I lose a whole bunch of customers. I wonder what's wrong with this page. You focus on problems, not features. You're not building features, you are solving problems for customers. And then you create a hypothesis about how you might solve that. So you have to run an experiment to see if you can make some impact on that problem through your current operating hypothesis. And then you analyze what happens, you come to some conclusions using data, and you do it again. This is the process we need to head to if we're going to give product teams an immediate connection with the impact of their work. So in order to do that, we need what I'm going to call full stack teams that have the whole end-to-end responsibility. They have a shared goal if there are multiple teams. They have full responsibility for reducing the friction that solving the problem that they're trying to solve. And they have an immediate connection with what they're doing. So a full stack team includes technical people, includes ops people, includes product people, includes designers usually, includes everybody who understands what business impact might be. They may be big or they may be small, but that team owns the responsibility. So you can't just have teams sort of having immediate connections with no framework. It's a constraints framework. You look at the true, valid constraints of the situation and say, these are the constraints you must live within. If it's not done by the time the event occurs, don't even start. Constraints are business constraints that can be expressed in a very few statements. This is the deadline. This is the amount of money. This is the friction that I am trying to remove. This is the conversion rate situation now, and we need to improve it by such and such. Most of the features we put in software systems are seldom or never used. Typically, you should never consider scope to be a valid constraint, because if it is, that means somebody else has designed a solution, not you. You're solving a problem. You are not executing scope. So scope is not valid. Time and cost are, generally speaking, the constraint. And they're usually the same thing. Time is usually the same as cost. So don't ask, how long is this going to take? Ask, what can we do in this window of time? Or what can we do for this amount of money? Secondly, then you want to manage progress, by rate or range, not by estimates or deadlines. Surprise, stuff has to work. You don't just have to get it done on time. When it's done, it has to work. Understand user needs. Number one, what we talked about in the first lecture. Decide what to measure. What a good idea. Where is the friction? How are we going to measure it? Install reporting platforms. Remember I showed you those different analytic platforms that you could install to take metrics, whether it's Google Analytics or whatever, you pick yours. Establish a baseline. How are we doing now? Aggregate the data. Analyze, visualize, and monitor, iterate, and improve. And in fact, if you look at the really, really reliable systems, if you look at Amazon, if you look at Google, if you look at Facebook, if you look at Dropbox, they're all built on internet. Internet is the least reliable stuff around, and the hardware that it's built on is cheap, cheesy, failure-prone cards, CPU cards, disks, and stuff like that. So the concept of failure is a concept of being able to detect and recover from failure without interrupting the user experience. That's how these big companies appear to be reliable. When software has to work, it's about a lot more than just writing programs. The most fundamental thing is monitoring, is keeping track of what's happening. This is the immediate connection with what's going on. But what do highly successful digital organizations do, and what don't they do that makes them successful? First of all, they don't do projects, and they're constantly evolving. There's no end point. They solve problems. They don't do estimates. They have a hypothesis that if I try this interesting new button that's not a like or a dislike, but something else, it's going to cause this kind of behavior, and they test the hypothesis. It's not a feature, it's an experiment or a series of experiments. They don't actually have IT. They have full stack teams. Software engineers are in the line organizations every time. They do test-driven development. They don't do periodic releases every couple of months. They deliver every day. Okay, so we're way past iterations here, okay? That's no longer a concept, not with an immediate connection and feedbacks. They don't do outsourcing. That doesn't mean they don't use people that are not in the company, but those people are part of the full stack team and part of the team that has the immediate connection with the experiments and the hypotheses. They do microservices, or they do an automated deployment pipeline or something like that. And the companies that do a really good job of that, of using the data and making good products with it or good government service with it, this is the kind of stuff that they do. And this is that they do. And this is what they don't do.